So understand that I will not be teaching how to program. Unity is much bigger than programming. So I hope that you have some experience. Now, the programming language that Unity uses is C Sharp. If you know Java, it's very similar. It's an object-oriented language. So we have a lot to cover. So let's get started. In Unity Hub, go to the Projects tab and click New. Select 3D and name the project whatever you want. I already have a project prepared. I call it Unity Tutorial. To open your project, make sure that you have set the version to 2019.4.0F1 for this particular workshop and click the name. And now your project should be open. Don't worry if your editor doesn't look exactly like this. This is the layout that I personally prefer to use. If you would like to work with this layout, go to Window, Layouts, and click 2x3. Now already there's a lot going on here. But let's talk about what's going on the left side of the screen. Over here, you can see the game world from a limitless view. If you use the middle scroller on your mouse, you can view forward and view backwards. If you right click, you can you can rotate your view. If you left click, you can highlight things. Over here is the camera. The camera is already one of our game objects that is placed into the world along with directional light. So let's talk about actually game objects. Let's create a new game object. Let's say a cube. Now we have a cube. There's a lot of ways we can move this. By clicking here, we can move it through the x-axis, the y-axis, and the z-axis. We can also rotate this by clicking on the Rotate tool. Again, we can do this based on the different axes. Now you'll notice the bottom screen is displaying something different from the bottom screen. The bottom screen is what is going on from the player's point of view. If we moved the camera, since the camera is also a game object, the player's perspective changes because the camera is what the player sees. Think of a movie. The camera is basically used in the same way. Of course, Unity also provides additional 3D models. So let's add in our demo a sphere. And we're also going to add another cube, but we're going to make it kind of a rectangle. So we're going to use the scaling tool. Just like the other tools I've discussed so far, you can use all three different axes. We are going to extend this. We are going to use this as something the ball can roll on. You can also make your own 3D models in Blender and import them into Unity by converting them into 3D model objects. However, I would not be covering this in this tutorial. Click on the sphere object. Let's look at the inspector. Here we can see the positions and the rotation and the scale of our object to different axes. You can move them like this. Another thing we got here is a sphere collider. The cube also has a box collider. And when we get to scripting, we'll start using the box collider to check collisions between objects. But for now, go make sure you got sphere clicked, and we are going to add a component, and we are going to add rigid body. Using the rigid body, we are going to make use of the built-in physics system in Unity. Here we have a mass specified, and here we got gravity. I don't want you to worry about these two for now. If I hit play, oh, hold on. So now if we hit play, the ball will go down until it comes contact with the cube. So it goes down due to gravity. If we turned off gravity, it wouldn't move at all. But how does it know when it is in contact with the cube or the rectangle? Whatever, it's a cube object. The reason it knows is because it comes into contact with the box collider. So this is what the box collider is used for. It's used for collision detection. If we turned off the box collider and then turned gravity back on and then hit play, the ball will go straight through the cube / rectangle. So I'm going to turn the cube's box collider back on. And I want to show you another cool thing that you can do while you hit play is you can still move the game objects. So watch this. I'm going to move this back up. Oh, it's going back down. Move it back up, down. So why don't we take the cube, rotate it, and hit play. Pretty cool. We can add some constraints on a sphere. If we click freeze position X, it will no longer be able to move its position in the X direction. You can still see it rotating, but its position is not changing. We could do the same for the y direction. These constraints also exist for rotations. If we clicked all of these and hit play, the sphere will not rotate at all. Now, just for fun, why don't we see what happens if we give the cube a rigid body? Now we're going to hit play. So the cube has gravity turned on, as you can see, so it's just going to go down infinitely. It's got nothing to land on. So why don't we turn gravity off and see what happens again. Now the ball is pushing it down. Let's make the mass of the cube some giant number. Now, as you can see, the collision from the ball is not such a big impact. Let's play around with the constraints. If we freeze its y position, of course, it's not going to go down in the y direction. Let's see what that looks like. Now, since it's not moving in the y direction, it's just kind of flipping. What if we rotate it? What if we froze its rotation? It still moves a little bit. If you've taken a physics class, you probably know what's going on. Before we get into scripting, click the cube, revert its rotation to all zeros, and remove its rigid body. Click on the sphere, add component, new script. And we're going to call this sphere script. Now open this up in your favorite text editor. Mine is Visual Studio Code. By default, these scripts will have two functions already. Start, which is called before the first frame update, and update, which is called once per frame. Basically, start is run immediately when the object is instantiated. In Unity, click Window, General, Console. We are going to use the console to demonstrate the two functions in our script. In start, type in debug.log hello world. Don't forget your semicolon. Go back to Unity. Hit play. Now we can see here in the console, sorry, the window, general, console. So as you can see, the debug.log function prints to the console. Here we have printed hello world once. If we took this, put it in updates, and made it like hello world 1, and save, check the console again, you can see the time frame of the print statement happening. Hello World 1 is being printed every frame. What's a frame, you might ask? The screens that we look at are evolved forms of the flipnotes that were used to create old cartoons. And flipnotes had a bunch of pages. Right? If you drew a ball here, and next page you drew it here, it looks like it was going this way. Those are 2 frames that were used for creating the early cartoons. And an advanced form of those frames are used to display screens today, including for video games. Between the opening bracket of the class, before the start statement, type public rigid body RB. And in the start function, RB equals get component rigid body. What this will do is it will give us a reference to the rigid body attached to our sphere. And what we're going to do with this is we're going to use it to move the sphere. In the update function, RB dot velocity equals new vector 3 0 0 10. So what we're doing here is we're setting the velocity to a new value every frame. In this case, the velocity will have a consistent speed of 10 in the z-axis. So now, if we hit play, uh-oh. I'm sorry, I spelled component wrong. Now, if we go back to Unity, and run it. It's just going in the z-axis. We could increase that speed a little bit in every update. Let's set this to 0 and make a public integer I, and in start, let's set I equal to 0. Let's put I here, and we'll do I++. And now let's go back to Unity. Now it goes faster every frame. We'll go back to scripting soon. Let's remove all this. Now, what if we wanted multiple spheres? Obviously, we could just copy it, paste it, and we got another one. You move its position, it's another one. Paste it. Yeah, we got another one. But what if we wanted to change one thing about it? Like suddenly we need its mass to be 2. Well, the mass of this one is still 1, and we want the mass of all of our spheres to be 1. This is going to be annoying if you got to have like 100 spheres or something. If you suddenly all those spheres have to be 100, that's going to be a lot of time being consumed. So what we are going to do instead of that, in this hypothetical situation, which I'm using to teach, we are going to create prefabs. Create a new folder called prefabs. Go into the folder, drag in the sphere, and now if we want to have multiple spheres, drag it in here, just move its position, and now, for example, if you changed the scale of the prefab, say it's Y scale, it'll apply to all of them. But we are only going to use one sphere for now, but that was just a demonstration for why we're going to use prefabs going forward. Let's set its scale back to 1 because it looks weird. Go to Window, Package Manager, and look for the input system. I already have it open, but you could go into the search bar and search for it. Make sure that you have the newest version. If you don't, it'll have an update option here. Also, we are going to make a new folder called scripts. And all of our scripts will go in here. So now in your scripts folder, right click, create, input actions. We're going to call it player controls. Now let's open it. And we got 3 columns here. Let's talk about input actions. Input actions represent different control settings for different circumstances. For example, your character might control differently on the land, or in the water, or in space. We're just going to create one for now, and we'll just call it main. And we are going to create an action, or just edit the one over there. Just rename it move. We are going to get our character, or our sphere, to move. If you don't know what actions are, actions describe the actual actions that will occur in our action map. We are going to set our action type to value, and our control type, sorry about this, we are going to set our control type to, we're going to call this vector 2, movement. Click path, click listen, type W. For up. For down, go to path, click listen, type S. For left, click path, click listen, type A. Click A. And now we're just going to add one more action called jump. Click binding, hit path, listen, hit the space bar, hit space. Now, as I'm sure you're guessed, what we're defining is, and now we are just going to save this by clicking save the sphere. Asset. We're going to move up with W, down with S. Back to Unity, and we're going to select our sphere. We're actually going to remove our rigid body, and we're going to add a different component called character controller. This is specifically to be used if you want to control what you're using. So I wasn't able to show it before because the take got corrupted, but what I did was I clicked here. Ignore this. I clicked here and I entered player controller in C# class name. That is player controller. That's what you want. And I hit apply, and that generated this C# file. In Unity, open up Sphere Script. Okay. We are going to obtain access to our player controller. So first, let's initialize the variable for it. Private player controller. I'm sorry, private player. private player controller. We're just going to initialize it there, and we're going to add a new function called awake. And awake is called when the game starts, as opposed to start when the object is instantiated. Yeah, and awake is called when the game starts. So inside of this function, we are going to initialize controller to new player controller. And then we're going to define our speed for our sphere. Now we could just do private float speed equals 10f, but the problem is if we want to test out different speeds, we want to be able to do it quickly. And there is a way to do that within Unity without having to go back to the script. The way to do that is to make it a serialized field. So open bracket, serialize field. While I'm here, I'm going to cover two more functions. First of all, private void on enable and on disable. On enable is called whenever our game object is enabled, and likewise on disable is called whenever our game object is disabled. So go to Unity, just to show you what I mean. There's a way to enable and disable a game object. Right now it's enabled. If I remove this check mark, it disables it. And I could enable it likewise. If you want to control whether or not it is disabled or enabled, the game object has a variable called enabled. And you can set it to true or false. All right. So what we're going to do with this is in our enable function, we're going to do controls dot enable. Enable is another way you can enable the function, probably a better way than the one I just mentioned. And controls dot disable. Now, first, let's get a reference to our character. We are going to check the movement of our player. So we will do private character controller character controller. And then our start function, character controller equals get components. I don't know why I was hesitant. All right. To check our movement, we are going to create a vector. Vector 2 move input equals player controller. I'm sorry. Whatever we called the variable, controller dot movement. You probably want better name conventions than that. This is just for the workshop. Dot read value vector 2. And then we are going to obtain a move vector. Vector 3 move vector equals transform dot right times move input dot x plus transform dot forward times move input dot y. Now let me try and explain this math. So this is a three-dimensional vector. Transform dot forward is the transform. Okay, transform is the transform of our game object, and right is its right transform, and we are simply multiplying it by the x value of our move input, which is positive if the user enters D, negative if the user enters A. And likewise, we got the forward transform of the game object, and it's multiplied by move input dot y, which is positive if the player enters W, negative if the player enters S. Next, we are going to do character controller dot move vector dot normalize times speed times time dot delta time. Essentially, if we didn't have this, time dot delta time is the time a lot of units in frame. 1 second. So if we didn't have it, it's going to move just the right amount each frame. So always use this when moving something. Uh-oh. It looks like I made some errors. Luckily, the console will tell us about these errors. We got method must have return type in line 11. Ah, we forgot to put void in here. Okay. Ah, it's not controls, it is controller. And in our project, we made this main. Although movement is probably a better name. Opening up Unity. And these errors are gone. Now let's test it out. Hey, our ball moves. Of course, it's not going down because we don't have a rigid body. So by default, we could still add a rigid body. This will work for our main. I'm not going to do that. I'm going to explain one more thing, since we have that is collision detection instead of a rigid body. But I want you to try this function on anything else that has a rigid body, and it will be called whenever it collides with another object. And that's the basics of Unity. Thank you for watching.